This is an intro video on area and volume. The first thing I want to look at is the distance between these 2 points. So if point A is 310 and let's say point B is 910, I want you to think for a second about how far apart those points are. And so it should be pretty clear that the distance there is 6 because the distance is exactly horizontal. If the point B were instead of 9 comma 10, let's say it was 1210, then the distance between those points is 9. In order to do that, we're doing a horizontal distance. And the way we're taking the horizontal distance is we're taking the x value on the right minus the x value on the left. That clearly works for all positive values of x. What if we have another point C where it's over here? So let's say it's at the point -2 comma 10. Okay, so does it work to take the right x minus the left x if we're trying to get the distance between A and C? So that would be 3 minus -2, which is 5. That does work because the distance from -2 to 10 is 2, or -2 to 0 is 2, and from 0 to 3 is 3, and so that distance is 5. So 3 minus -2 works. If both of the points have negative values of x, it also works. So if I have a point D that's at -9, 10, then the distance there is 7, and we could compute that by doing -2 minus -9. And so as long as the distance is precisely horizontal, meaning it's exactly right to left, they're at the same y coordinates, then the distance between 2 points can be found by taking the x on the right minus the x on the left. Vertical distances can be done in a similar way. So if I wanted to do the distance between the point A 310 and the point B 34, then that distance is 6, and we take the top y minus the bottom y. And again, it has to be vertical, which means the x coordinates would be the same, but that always works. That works for positive values. If I have a point C where it's at -1, I'm sorry, 3 comma -1, not -110, 3 comma -1, then it's vertical. The distance from A to that point would be 11, which we can compute by doing 10 minus -1, or just thinking through the distance that is 10 units to the x-axis and then another unit to get down to C. But we can do the top y minus the bottom y. That seems relatively straightforward. That is relatively straightforward. But when we do area volume problems, which we'll get into soon, though, this becomes something that's real important to keep track of. So I want to look at something slightly different. So I've got two graphs on the screen. We've got y equals 14 minus x squared, which is the parabola that's opening down. And then I've got y equals x plus 8, which is the line that you see there. The graphs are exaggerated a little bit to look at the intersection or the overlap between the two curves. I want to find the intersection points real fast, so let's see where they intersect. To do that, we set the two equal to each other. And so we do 14 minus x squared equals x plus 8, and we solve that for x. To solve that, you get 0 on one side, so I'm going to add the x squared, I'm going to subtract 14, and now I'm going to factor that and get x plus 3, x minus 2. That gets us x is -3 or x is +2. That means this point is the point 2 comma 10, and I can get 10 by plugging the 2 into either equation, and it's smart actually to plug it into both of them to make sure we get the same thing, but we get 10 on both of them. And then if I plug in -3 for this point, I get 5 for the y value, which means that might be a little low there. Let's move the x-axis down just a little bit. Again, not to scale, that's okay, but I just kind of want to see where everything is relative to each other. And again, we're getting the 5 by plugging the -3 in for x on either one of those equations. Okay, so that's how we find the intersection. Now, what I want to look at is I want to say that point A is a point on the top curve. Okay, so A is a point on the top curve, but we don't know where it is. It's somewhere between the two intersection points. So it could be as far left as -3 or as far right as +2. So maybe it's actually over here. We're not going to specify, but it's somewhere between the two intersection points, and it is on the parabola. Point B is somewhere, again, between the 2 points, and we're going to say at the same x value as A, so it's directly below A, but it's not necessarily where it looks like it is. So maybe that's not really -1 or -2. It might actually be where it's positive, so maybe it's over here. But anywhere between the two intersection points. Okay, and so what I want us to do is I want us to look at a series of problems where I want us to find the distance. First, we'll say from A to B. If they are where, and so the first problem will say they are where they look like they are. So let's say they're at -1. So find the distance from point A to point B if the points are where x is -1. All right, see if you can figure out a way to do that problem, and then pause the video and try that, and then we'll work it together in just a second. Okay, so to do this, this is a vertical distance. So because we specified they're at the same x value, they're straight up and down, so it's a vertical distance. So we're going to take the top y minus the bottom y. Okay, the top y is whatever the y coordinate is at point A. So at point A, the top y, you plug -1 into the function. So we should get 13. Point A is on this function. Okay, so A is on this. And so if I plug -1 in there, I get 14 minus +1, which is then 13. And then the bottom y, B, is on this one. So then the corresponding y value when x is -1 on that is 7, and so the distance between the two is 6. Okay, so I want you guys to try it, and again, please pause the video and do this. I want you to try it for x equals -2, at x equals +1, and at x equals pi over the square root of 10. Okay, so pause the video, see if you can come up with those distances, and then we'll check them together in just a minute. Okay, so again, we're going to do the top y minus the bottom y. So for number 2, we want the y value at x equals -2 for point A. Well, point A is on the parabola, so I plug -2 into 14 minus x squared. That gets me 10. And then point B is on the line, and so I plug -2 into that, and I get 6. And then just so we're clear, the way I'm getting this is I'm doing 14 minus -2 squared. The way I'm doing this is I'm doing -2 plus 8. And so we get 4. The point of this is not that you can do 10 minus 6. The point is what you're subtracting, what the order that you're subtracting them in is, and how you obtain the numbers. Okay, so we do 10 minus 6 because it's the top one minus the bottom one. It's top y minus bottom y. The 10 is because it's the y value on the parabola. The 6 is because it's the y value on the straight line. So when I go to x equals 1, that's granted to the right of the y-axis, but the y value for point A is 13 because I plug 1 into the parabola. The y value on point B is 9. And so we get 13 minus 9, which is again 4. Again, the point again is not to get the answer 4. The point is, how do you get 13? How do you get 9? Why are you subtracting them in that order? Number 4 is x equals pi over radical 10. Well, we can't simplify this a whole lot, but we would get 14 minus pi over radical 10 squared for the y value at point A, and we would get pi over radical 10 plus 8 for the y value at point B. And then you could do some simplification here, but again, that is not the point to simplify something that crazy. The point is, really, we're doing the same thing we did on the first 3 problems. Okay, and so the 5th problem is, let's say, find the distance from A to B if they are, instead of where, at any point between the intersections. So I want a formula that would work where you include x. So whatever x is, what would you plug that into to get this answer? Pause the video, take some time to try to figure this out, and then check the answer with me in a minute. Okay, so if I just tell you this is at whatever x value, okay, so if this is at whatever x value, you still take the top y minus the bottom y. The top y is 14 minus x squared. The bottom y is x plus 8. And you could simplify that to negative x squared minus 8 plus, minus x plus 6. So you can get negative x squared minus x plus 6 as the answer. But again, the real point is not that final answer. The point is that you're subtracting in that order. So you're taking the top y. Well, the y value at point A is whatever 14 minus x squared is. The y value at point B is whatever x plus 8 is. That's exactly like this, where you can't really do much simplification. Okay, so I want to now look at some more related to the same diagram. So we're going to erase these for a second. And then, whoops, man, give me 1 second here. And we're going to talk about, instead of the distance from A to B, we're going to talk about the distance from each of those points to certain lines. And so this is a little weird at first. But let's start with the line y equals 3 to A, and from y equals 3 to B. If A and B are at, and so number 1 is x equals negative 1 again. Okay, so we're going to talk about, so we're asking 2 questions on each of these. So on number 1, we're saying find the distance from the line y equals 3 to the point A, and from the line y equals 3 to the point B, if A and B are where x is negative 1. So first, let's draw in the line y equals 3. Y equals 3 is a horizontal line. It's under the region because it's under that bottom intersection point, negative 3, 5. Okay, so from point A to the line y equals 3, what I mean by that is the closest distance, the most direct distance from point A to the horizontal line y equals 3. If we look at that distance, the distance from point A to y equals 3, that is a vertical distance. So you take the top y minus the bottom y. But what we're telling you is that x is negative 1. So within that distance, the top y is 13 because you plug that in to 14 minus x squared to get the y value there. within that distance, the bottom y is 3, and so we get 10. Again, the important part is not the final answer 10. The important part is how you get those two numbers that you're subtracting, why you're subtracting them in that order. So you're taking within the distance that we want from A to the line. The top y happens to be the y value at point A, which is 13. You get that by plugging -1 into the first equation. The bottom y is the y value on the horizontal line, which happens to be 3. Okay, so from point B to the line x equals -1, again, that is a vertical distance. It's the distance from the y value there to the y value at the line. And so we do the top y minus the bottom y. Well, the y value at point B is 7 because you plug -1 into the equation for the line. The y value on the line, the horizontal line, is 3, and so we get 4. And again, the number 4 is not important. It's how you get 7, how you get 3, and why you subtract in that order. Okay, so now I'd like you to try a couple more. So the same thing, the distance from the line y equals 3 to A and the line y equals 3 to B. If A and B are at, let's say first, x equals +1. Number 3 is at x equals, let's do something weird again, like we'll do pi over radical 10 again. And number 4 is at any x in the interval -3, 2, so in the intersection, or in the overlap of the region. Okay, pause the video, try those problems, and check with me in a few minutes. Okay, so for number 2, again, the distance from A to that line is a vertical distance. So within the region, A is always on top of the line, so we do top y minus bottom y. The top y again happens to be 13 because we plug 1 into the equation. The bottom y is 3, and so we get 10. For point B, the top y is the y value on the slanted line. The top y is 9 because we plug 1 into its equation. The bottom y is 3, and so we get 6. For problem 3, the y value at point A is 14 minus pi over 10 squared, pi over radical 10 squared. The bottom y is 3. For point B, the top y is pi over radical 10 plus 8. The bottom y is 3. So when we talk about, whoops, I should have done that in red, but we're just going to leave it for now. So when we talk about any x for point A, it's top y minus bottom y. Well, the top y is 14 minus x squared. The bottom y is 3. Happens to simplify to 11 minus x squared. And we'll fix it for this one and put point B. The top y is the y on the slanted line, x plus 8. The bottom y is 3, and so we get x plus 5. And again, it's the order of the subtraction and how you come up with what you're subtracting that's the most important here. Okay, I want to do several more examples, but everybody should now think about this would be the same if we were doing, instead of y equals 3, let's say I was doing the line y equals 1, or y equals -7, or the x-axis. All of those would work the same way, but instead of y equals 3, we're using y equals 1, and because it's underneath the region, these 3's would become 1's, or they would become -7. Or if it was the x-axis, y would be 0, and so the 3's would become 0. You would still be subtracting, but it'd be something minus 0. The problems actually change a little bit when we talk about a line above the region. So any line above the region, we're going to handle the way we just did. any line below the region, we're going to handle the way we just did. Any line above the region, like 20, it's too thick. Any line above the region, like 20, we're going to handle a little bit differently. And so let's do the same problem set. So we're going to erase this stuff. And we're going to do y equals 20 for the same x values. Okay, so I want you to pause the video and actually try these on your own. So they're a little different, but not a lot different from the ones we were just doing. But do all 4 of them. So pause it and say, okay, I want to know the distance from the line y equals 20 to point A and from the line y equals 20 to point B at each of those 3 x values, and then a formula in general for any x. And then just to help real fast, at y equals 20 would be a line up here, somewhere above the region, because this y-intercept on the parabola is 14. So pause the video, take a few minutes to try that problem, and we'll work it together in just a minute. Okay, so when we're doing this problem, for number 1, we want the distance from y equals 20 to A. That again is a vertical distance. So we're talking about the distance between the top y and the bottom y. So for point A, the top y is 20. The bottom y is whatever I get when I plug -1 in. So it's 20 minus 13, which is 7. For point B, it's the top y minus the bottom y. The top y again is up here. The bottom y is now wherever B is. So we take the top y minus bottom y, but the top y is 20 this time. The bottom y happens to be 7. Okay, on number 2, we're going to again take the top y minus the bottom y. We get 20 for the top y, 13 for the bottom y, which is 7. On B, we do take the top y 20. The bottom y is now 9 because we're plugging 1 into the slanted line, and we get 11. For number 3, top y is 20. Bottom y is 14 minus pi over radical 10 squared. For part B, or for point B, top y is 20. Bottom y is pi over radical 10 plus 8. On number 4, we're talking about any x in the region. So when we talk about the distance from y equals 20 to the point A, we do 20 minus whatever the y value would be. The y value would be 14 minus x squared. That simplifies to x squared plus 6. For part B, top y is 20. Bottom y is x plus 8, which simplifies to negative x plus 12. This problem set would be basically the same for any line above the region, any horizontal line above the region. So y equals 30, y equals 14, y equals 15. All of those would work almost exactly the same way. Okay, so now I want to look at 2 more lines where we do basically the same thing, but not horizontal lines. So those were horizontal lines. We're going to now talk about vertical lines to the left and the right of the region. And so we'll start with x equals 5. So we want the same questions. So the distance from the line x equals 5 to A and from the line x equals 5 to B if A and B are at each of these values. This time, x equals 5 is a vertical line, and it's to the right of the region. So when we look at the distance from point A to the line, we're talking about the distance from this vertical line to the point A over here, and so that's a horizontal distance. we take the right x minus the left x. For point B, we're doing the same thing, the distance from the x here to the x here, and so we take the right x minus the left x. Pause the video and do this for problem 1 only. Real important you do it before I do it. So do it before I show you, but do problem 1, pause the video, and then check it with me in just a second. Okay, so on problem 1, that is a horizontal distance. You take the right x for point A, which would be 5, minus the left x, which would actually be -1. And so you get 6. You do not plug the -1 into this equation because this equation is giving you the y value when you plug in x. You don't want the y value here. You want the right x minus the left x, and the x value is -1. What that means is point B is exactly the same thing. It's the right x, which is 5, minus the left x, which is given to you, that's -1, and so we get 6. Now pause the video and do the next 3 problems. Okay, so for both of these on number 2, we should get 5 minus 1, which is obviously 4. On number 3 for both of them, we get 5 minus pi over radical 10. And on number 4, we get 5 minus x. Real important that, first of all, this is easy, but it's easier to mess up because you don't have to do very much. You're given the x value, which is what you want, and so you don't need to plug it in anywhere because you want the x value and that's what you've got. Rather than working through completely, well, let's do work through completely, change my mind. Let's go and try x equals -4 to A and from -4 to B. Pause the video and try all 4 problems on your own, and then check it with me in just a minute. Okay, so x equals -4 is a vertical line over here somewhere, probably not quite as far as I've drawn it. For A and B, we're looking at horizontal distances. We're looking at the distance from the right x to the left x, so we do right x minus left x. They're the same on both of these. So we're going to do the right x for A is -1 minus the left x, whoops, x equals -4, didn't label it right. -4. And so right x minus left x is -1 minus -4, which is then +3. B is exactly the same because it's the same x value as A. So -1 minus -4, which is +3. You do it that way because you do the x on the right minus the x on the left, and this time the line is to the left of the region. So here we get 1 minus -4, which is 5. Here we get pi over radical 10 minus -4, which you can simplify if you want. Here you get x minus -4, which simplifies to x plus 4. Okay, now it's real important that you go do the worksheet called Intro to Volume and Area. That worksheet should be completed before you advance to any other videos. Thanks for watching.